Today, we're going to show you 20 astonishing meteorites that shook Earth. Some of these meteorites fell recently, like one in 2020, and they brought rare elements with them. Strap in, hit that subscribe button, and let's blast off into the universe of meteorites. It's going to be out of this world. And remember, stick around until the end because the number one meteorite is so big and so incredible that you won't want to miss it. Canyon Diablo. The Canyon Diablo meteorite is associated with the meteor crater impact site in Arizona, USA. It is estimated to have struck Earth approximately 50,000 years ago. The original size of the meteorite before impact was about 50 meters in diameter, which is roughly equivalent to the size of a medium-sized office building. The impact of the Canyon Diablo meteorite created the famous meteor crater, which is approximately 1.2 kilometers or 0.75 miles in diameter and 170 meters or 560 feet deep. The impact released an enormous amount of energy, equivalent to several nuclear bombs. However, it struck a relatively uninhabited area, and as a result, it did not cause widespread destruction or fatalities. Instead, it formed one of the best preserved impact craters on Earth, which is of great scientific interest. The composition of the Canyon Diablo meteorite is that of an iron meteorite, primarily composed of iron and nickel, with traces of cobalt and other elements. While it does not contain gem-quality diamonds, it does contain small diamond-like graphite crystals. Some fragments of the meteorite also contain traces of rare elements, which have been of interest to researchers. The Canyon Diablo meteorite has contributed significantly to our understanding of the early solar system, organic chemistry, and the geology of impact craters on Earth. Siro Alen Meteorite. The Siro Alen Meteorite is an iron meteorite that impacted Earth on February 12, 1947 in the Siro Alen Mountains of Russia. This meteorite is notable for its dramatic entry into Earth's atmosphere, producing a bright fireball and loud detonations. It broke apart in the atmosphere and rained down numerous fragments. While the Siro Alen meteorite is not known for diamonds or rare elements, it is a well-studied meteorite due to its historical significance and the large number of fragments collected. These fragments have provided valuable insights into the physical characteristics and composition of iron meteorites. The Siro Alen meteorite is primarily composed of iron and nickel, and it is admired for its regmiglyphs, which are thumbprint-like depressions on its surface caused by ablation during its descent through the atmosphere. Agal Meteorite. The Agal Meteorite is an ordinary chondrite meteorite discovered in the Agal region of Morocco. It is believed to have originated from the asteroid belt between Mars and Jupiter, making it a stony meteorite. This meteorite primarily consists of silicate minerals and is known for containing kamacite and troilite, two metallic minerals often found in meteorites. Kamacite is an alloy of iron and nickel, while troilite is an iron sulfide mineral. Regarding size, the Agal Meteorite typically exists as smaller fragments rather than large intact meteorites. It is not known for containing diamonds or significant rare elements. Instead, its scientific value lies in its classification as an ordinary chondrite and the presence of kamacite and troilite, which are characteristic of such meteorites. If you like this video so far, leave a like, and you can also check out 15 lucky people who found the rarest things and became millionaires overnight on our channel Forever Green. And while you are there, don't forget to subscribe to our channel and hit that bell icon so you never miss a single upload. Now, let's get back to our video. Tunguska Meteorite. The Tunguska event, which occurred on June 30th, 1908, over the remote Tunguska region of Siberia, Russia, is one of the most significant celestial events in history. It was caused by the airburst of a celestial object, likely an asteroid or comet fragment, in Earth's atmosphere. The explosion unleashed an incredible amount of energy, equivalent to several atomic bombs, resulting in a powerful shockwave and widespread devastation. The Tunguska event's destruction was extensive, flattening an estimated 80 million trees over an area of about 2,150 square kilometers. 830 square miles. Remarkably, there were no known human fatalities due to the remote location of the event. Unlike typical meteorite falls, the Tunguska event did not result in the recovery of large meteorite fragments. The celestial object disintegrated in the atmosphere, causing the explosion, and no significant meteorites were found. This event is unique in that regard. Murchison Meteorite. The Murchison Meteorite, which fell on September 28, 1969, near Murchison, Victoria, Australia, is a carbonaceous chondrite meteorite. It's notable for containing a rich array of organic compounds, amino acids, and rare elements. This meteorite is considered one of the most significant meteorites due to its potential insights into the origins of life on Earth and the early solar system. In terms of size, the Murchison meteorite is estimated to have been about 100 kilograms in weight when it entered Earth's atmosphere. However, it fragmented during its descent, and numerous fragments were recovered. These fragments were collectively found to contain more than 15,000 different organic compounds, including amino acids, which are the building blocks of life. While the Murchison meteorite contains various organic materials and rare elements, it does not contain diamonds. Mundrabilla Meteorite. The Mundrabilla Meteorite is an iron meteorite that was discovered in Western Australia, specifically in the Mundrabilla Station area. It is a part of the larger Mundrabilla group of meteorites. These meteorites are believed to have originated from the asteroid belt between Mars and Jupiter. In terms of composition, the Mundrabilla meteorite is primarily composed of iron and nickel, with traces of cobalt and other elements commonly found in iron meteorites. It is not known for containing diamonds or significant rare elements. Iron meteorites like Mundrabilla are known for their distinctive metallic appearance and often display a characteristic pattern called the Widmanstätten pattern when etched with acid. Regarding size, individual Mundrabilla meteorites can vary in size, but they are typically not as large as some other meteorites. They exist as fragments rather than intact meteorites. In summary, the Mundrabilla meteorite is an iron meteorite composed mainly of iron and nickel, with traces of cobalt and other elements. Nantan Meteorite. The Nantan Meteorite is an iron meteorite that fell in the Nantan County of Guangxi, China in 1516. It is one of the most famous and well-documented meteorite falls in history. The Nantan Meteorite is classified as an octahedrite, referring to its crystalline structure. In terms of composition, the Nantan Meteorite, like other iron meteorites, is primarily composed of iron and nickel, with some traces of cobalt and other elements. It is not associated with diamonds or significant rare elements. The Nantan Meteorite is historically significant because it is one of the earliest recorded meteorite falls in China, and was highly prized for its metal content. It has been used for various purposes, including the creation of iron tools and artifacts by ancient Chinese civilizations. You think this is amazing? Wait until you see the number one. It will blow your mind. NWA869 Black Beauty. NWA869, often referred to as Black Beauty, is a Martian meteorite. It is one of the most famous Martian meteorites found in Northwest Africa, hence the NWA designation. This meteorite is classified as a Martian basaltic breccia, which means it contains fragments of various rocks and minerals. NWA869 is unique for several reasons. It is believed to have originated from the surface of Mars and was ejected into space during an impact event. It then traveled through space for millions of years before falling to Earth. The meteorite's age is estimated to be around 2.1 billion years. In terms of composition, NWA869 contains a mix of minerals, including olivine, pyroxenes, feldspar, and other rock-forming minerals. It is also rich in basaltic material, making it an important sample for studying the geology and mineralogy of Mars. While it contains a variety of elements and minerals, it is not known for containing diamonds or significant rare elements. NWA869 is primarily valuable for its scientific importance, as it provides insights into the geology and history of Mars. Chelyabinsk Meteorite. The Chelyabinsk Meteorite is associated with the Chelyabinsk meteor event that occurred on February 15, 2013, over the Chelyabinsk Oblast region in Russia. It was a significant meteor airburst event, often referred to as a superbolide. The meteoroid that caused the event entered Earth's atmosphere at a high speed, creating a bright fireball and a series of powerful explosions. The Chelyabinsk event caused extensive damage, including shattered windows, damaged buildings, and injuries to people due to flying glass. However, there were no reported fatalities. In terms of composition, the Chelyabinsk meteorite is classified as an ordinary chondrite, specifically an LL5 chondrite. It is primarily composed of silicate minerals, including olivine and pyroxene. While it contains various minerals and elements, it is not known for containing diamonds or significant rare elements. The Chelyabinsk meteorite is primarily significant for its association with a spectacular meteor event, and its scientific value in studying the physical properties and composition of meteoroids that enter Earth's atmosphere. It is not associated with gem-quality diamonds or economically valuable rare elements. Milb Meteorite. The Milb Meteorite is a type of carbonaceous chondrite meteorite, specifically classified as a CM2 meteorite. It was discovered in 1960 in the Milb Station area of Western Australia. Carbonaceous chondrites are a rare type of meteorite that contains a high proportion of carbon-rich organic compounds and water-bearing minerals. In terms of composition, the Milb Meteorite is primarily composed of various minerals, including olivine, pyroxene, and phyllosilicates. These minerals are often associated with water-rich environments and are considered important for understanding the early solar system's history and the potential delivery of organic molecules to Earth. The Milb Meteorite is not known for containing diamonds or significant rare elements. Instead, its scientific value lies in its unique composition, which can provide insights into the conditions and processes that occurred in the early solar system. It is considered an essential specimen for researchers studying carbonaceous chondrites. Escal Meteorite. The Escal Meteorite is a palisite meteorite, a type known for its unique composition. It was discovered in Argentina and is named after the town of Escal. Palisites are a rare type of meteorite that consists of both metallic and silicate materials. In the case of the Escal Meteorite, it contains olivine crystals embedded in an iron-nickel matrix. In terms of composition, the Escal Meteorite is a fascinating specimen. The olivine crystals within the meteorite are translucent and gem quality, making them visually striking. These olivine crystals are often cut and polished for use in jewelry, and they are sometimes referred to as peridot when used in this context. While the Escal Meteorite contains gem-quality olivine crystals, it is not primarily valued for diamonds or rare elements. Instead, its significance is mainly aesthetic and geological. It provides a unique opportunity to study the coexistence of metallic and silicate materials in meteorites, and is treasured for its beautiful greenish-yellow olivine crystals. Admire Meteorite. The Admire Meteorite is an ordinary chondrite meteorite that fell near the town of Admire in Lyon County, Kansas, USA. It is classified as an L6 chondrite, which means it contains primarily silicate minerals, and is one of the most common types of meteorites. In terms of composition, the Admire Meteorite is composed mainly of olivine, pyroxene, and metallic grains, with traces of other minerals. It is primarily made up of rock-forming materials and does not contain diamonds or significant rare elements. The Admire Meteorite is not particularly known for any unique or remarkable features, but it is valued by researchers for its representation of the ordinary chondrite class of meteorites. These meteorites are essential for understanding the early solar system's composition and evolution. Siro Meteorite. The Siro Meteorite is an iron meteorite that was discovered in the Siro area of Kenya. Iron meteorites, like Siro, are composed mainly of iron and nickel, with traces of other elements. They are known for their distinctive metallic appearance and often exhibit a Wittgenstein pattern when etched with acid. In terms of composition, the Siro Meteorite is primarily composed of iron and nickel, with some traces of cobalt and other elements commonly found in iron meteorites. While it contains metallic minerals, it is not known for containing diamonds or significant rare elements. The Siro Meteorite is primarily valuable for its scientific and geological significance. It provides an opportunity to study the characteristics of iron meteorites and their role in the solar system's history. Brena Meteorite. The Brena Meteorite is a well-known meteorite that has been found in several fragments in Kansas, USA. These fragments are associated with the famous Brena Palisite meteorite. Palisites are a rare type of meteorite that consists of both metallic and silicate materials, with olivine crystals embedded in an iron-nickel matrix. In terms of composition, the Brena Meteorite is primarily composed of these beautiful olivine crystals, which are often of gem quality and prized for their appearance. The meteorite's metallic matrix contains iron and nickel, with some traces of cobalt and other elements commonly found in iron meteorites. While the Brena Meteorite contains gem-quality olivine crystals, it is not primarily valued for diamonds or significant rare elements. Instead, its significance lies in its unique composition and structure, representing the Palisite class of meteorites. Tunguska Meteorite. The Tunguska Meteorite is an iron meteorite that was discovered in Toluca, Mexico. It is classified as an iron octahedrite meteorite, meaning it has a crystalline structure consisting of iron-nickel alloys arranged in octahedral patterns. In terms of composition, the Tunguska Meteorite is primarily composed of iron and nickel, with traces of cobalt and other elements commonly found in iron meteorites. Iron meteorites like Tunguska are well known for their metallic appearance and often display a Wittgenstein pattern when etched with acid. Similar to the Brena Meteorite, the Tunguska Meteorite is not primarily associated with diamonds or significant rare elements. Its significance lies in its representation of the iron meteorite class and its role in understanding the formation and differentiation processes that occurred in the early solar system. NWA869 Meteorite. The NWA869 Meteorite, often referred to as Northwest Africa. 869 is a type of ordinary chondrite meteorite. These meteorites are one of the most common types found on Earth and originate from various regions. NWA869 is believed to have originated from the asteroid belt between Mars and Jupiter. In terms of composition, the NWA869 meteorite is primarily composed of silicate minerals, including olivine, pyroxene, and other minerals commonly found in chondrite meteorites. It also contains various trace elements. While it does not contain diamonds, it is valued by researchers for its representation of the ordinary chondrite class of meteorites, which provides insights into the composition of the early solar system. Imilak Meteorite. The Imilak Meteorite is a meteorite that was discovered in the Atacama Desert of Chile, specifically in the Imilak region. It is classified as a Palisite meteorite, which is a rare type known for its unique composition, a combination of metallic iron-nickel and olivine crystals. In terms of composition, the Imilak Meteorite is primarily composed of olivine crystals embedded in an iron-nickel matrix. These olivine crystals are often of gem quality and are admired for their beautiful greenish-yellow color. However, the Imilak Meteorite is not primarily known for diamonds or significant rare elements. Instead, its significance lies in its aesthetic features, including the striking appearance of the olivine crystals against the metallic matrix, which makes it a favorite among collectors and meteorite enthusiasts. The LALI Meteorite. In 2020, the remarkable LALI Meteorite descended upon Somalia, creating a significant event in both scientific and local contexts. Falling in the vicinity of LALI, a town in central Somalia, this meteorite is one of the largest ever discovered, comparable in size to some of the largest structures known to man. Imagine something as massive as a small building or a section of a major sports stadium hurtling from the sky. From a scientific perspective, The LALI Meteorite is a treasure trove. Composed of unique materials, it possibly contains rare elements and could even hold traces of diamonds formed under the immense pressures of space. The LALI Meteorite, thus, stands as a monumental event from 2020, remembered for its grandeur, scientific value, and the minimal yet profound impact it made upon its unexpected descent to Earth. Hoba Meteorite. The Hoba Meteorite is a colossal iron meteorite found in Namibia, Southwest Africa. It is among the largest meteorites ever discovered on Earth, with an estimated weight exceeding 60 metric tons. This meteorite is composed primarily of iron and nickel, typical of iron meteorites, with traces of cobalt and other elements commonly associated with such meteorites. The Hoba Meteorite is historically significant for several reasons. First and foremost, its immense size sets it apart as a natural monument. Despite its massive weight, it did not cause substantial damage upon impact, and it remains remarkably well preserved. Unlike many meteorites that have been moved or excavated, the Hoba Meteorite is situated on the surface, making it easily accessible to researchers, scientists, and tourists. Its size and accessibility have contributed to its iconic status. Thanks for watching. Don't forget to like, subscribe, and stay tuned for more captivating adventures from Forever Green.